Well, since I dropped my Dodge off and it's out of here, we've moved all those tires and sorted and sifted and thrown away a bunch of stuff, and we're just going to keep going. We have the opportunity to make some changes to the shop, so that's what we're going to do. So I've removed fluorescent lights like these. They're them lights that only work sometimes. The weather's got to be right, the humidity has to be just right, all that kind of nonsense. So I went ahead and got LED lights and just rewired. The way they had these done was just Romex coming out of the ceiling, and then it went to the light. So I changed it and put boxes in with connectors up here with the duplex receptacle, and I just plug the lights in. That way, if I want to change out one of the lights, if it goes bad, it's real simple. Not very difficult at all. It takes just a few minutes. And we've got sorting some things out. I had all these stored over on this side, so we're trying to make good use of the shop. Getting the welding station set up here. We've got a 3x5 welding table coming from Northwest Indiana Fabrication. I'll leave a link to their website in the description here. But they build these 3x5 welding tables, and they're just incredible. I can't wait to get that. So I'm going to take the opportunity to upgrade some of the electrical. These receptacles that have been run here, this is completely unsafe. It should have never been done like this. They ran Romex on the outside of the steel siding and used staples to go and hold it in, and this is way too low. So we're gonna remove all this nonsense, and I got us some EMT and some boxes and receptacles, and we're gonna change it out from a single. We'll put in a two gang, it's called, which is 2 duplex receptacles, and it'll be much better. I got to run some more electric for the welders as well. The HTP welder runs off 50. The the TIG runs off of 50. I have a 30 amp here, which will do the plasma cutter, but this is kind of hopefully going to be the welding station, and then we're going to be putting a big table over here to put parts on and tools to work off of. But what a difference, man. And it's so much brighter in here. Hopefully we're doing more work in this shop than we used to, because it stays pretty warm in here and pretty cool. It's insulated very well. But anyways, I just thought I'd give you an update on what we're doing. Trying to get my lights up. We put up 8 lights so far. We have 8 more to go. So I better stop flapping my trap and get to work. The weekend's coming. We're less than 2 weeks away now, and I have got to get some stuff done. Alright, so I'm in the main panel for the shop, and I have isolated and turned off the circuits that we're going to be working on, and verified that they are turned off. Okay, so if you see this, I kind of went this way because I'm covering up existing holes, and that's where they ran the wire originally, and I couldn't move it over. Normally I would bring my conduit right in the center so I had room for expansion. I can come out of this and go that way, or come out of this one and go that way. This kind of limits it, makes it a little more difficult, but not able to be done. I always label every box I can. Circuit 29. That way I know if there's a problem, I know which one to turn off in the main panel because I can't see the main panel. Again, feed from panel A, circuits 5 and 7. This is panel B. We added another one down here. This is circuit 31, so we got 29, 31. Comes up here. We're going to do away with this because we don't use this. Hardly use any air anymore, but we do have a fitting right off the tank here. I don't want this to be in the way, so I'm going to plug that off. And then I changed some other stuff. There was, again, circuit 25. And then there was this here. This is a light switch for a light up in that attic. And it was just Romex coming down, so I changed that as well and added a plug because sometimes right over here I need a plug. So we got some other changes. I don't know if I'll do it now, but I'm gonna put a plug over here, probably at this area or maybe slightly higher, and another one here with 4 plugs and 4 plugs, and I'm gonna put a shelf here with my Milwaukee chargers. So all my Milwaukee batteries will be here, and then I'll put a shelf up like this to hold the chargers with a lip on it, and a shelf below that we can set the batteries in, or buy those holders that screw to the bottom that the batteries can sit in, and keep all my chargers behind this door where they're protected and out of all the grinding dust and stuff. Next thing I need to do is get a power source over here for the Inverteg 251 and the ProPulse 220. Both of those machines pull 50 amps, or rated at 50 amps at peak. So I'm gonna bring power over here and make a corded connection so that we can plug one in or the other. Now the Inverteg will probably stay here because we're gonna have a big 3x5 welding table here. That small welding table will be small enough that we can move it all throughout the shop. So there are provisions in the electrical code, the National Electric Code, that says if you're gonna run a conductor, a circuit for a welder, that you can derate, or you can use a smaller gauge wire to feed that based on the duty cycle. Duty cycle is a percentage of time that it's pulling a load versus the time it's not. Basically, so you're gonna ramp up at the amperage and then it's gonna shut off and back and forth. So just like TIG welding, you run a bead, it cools off. So if you have a 50% duty cycle, that means you like weld for so many times, and for however long you welded, it cools for so much time and so on. The machine cools down, the conductors cool down, and what have you. The problem is, in the code, it says you can do that when you derate. However, it needs to be a machine that is permanently attached. So if once you create a situation with a plug like this and a male end like this, it is no longer permanently welded. It was no longer permanently connected. So this welder would have to be permanently wired in here with basically like a disconnect that you could just turn off, but not disconnect the actual wires by unplugging. Because otherwise you could have a situation where you ran a smaller conductor wire to it, unplug that, and then you plug something in that doesn't have a 40%, 20% duty cycle, whatever the case, and it pulls 50 amps continuously. So now your smaller gauge wire starts to heat up. You end up with the insulation starting to get damaged, possibly a fire, and so on. So I just don't do it. If that's a 50 amp circuit, we're going to run wire that's able to carry 50 amps. I don't like running aluminum wire. I run copper wire. In this case, I'm going to run 6.2 with ground, and 6.2 is good for 55 amps based on the insulation around each conductor and the jacketing that's on there. And I'll put a table here to give you an idea. Just because it's a certain gauge wire doesn't necessarily mean it's going to carry that ampacity unless it has the right insulation and jacketing for the load and the environment that you put it in. So I'm using NM because we're going to be inside the wall, not a big deal. But now I'm going to get it running and we'll get it into the panel. I just want to check my gauge and make sure I'm stripped back far enough, because you got to make sure that the screws are not at the very end, or it will just it'll just tighten the end of it up and then it can slide out. So I tend to go just as far as I can to get in the middle of the threads. There we go. See how I was able to get that in still? Now I know that there's plenty of threads past that, or plenty of copper past the point where we're crushing it like this. Okay. Now I have our other conductor here. See, the ground comes in, hits a ground screw, and what that's doing, that ground is bonding this box. So this is personal protection. This is so you don't get hurt. When I put this in here, because this is a smaller wire, this is like a 10 wire, these are 6 wires. So I'll take that end and I bend it over and I crush it this way, and that gives me more surface area to put the screw into. Anything I can do to help make it a better connection. You see, this is black tape because this was 6'2" with the ground, and that was a white conductor. So it's to signify that it's no longer a neutral, and it is a different leg, different phase of the box. I put black tape on it. I'm going to try and push that up all the way and tighten this up. So get this started. I'll switch over to a bigger flat blade screwdriver if I need to. I think this is getting it. Yeah, okay. Now double check everything. Make sure it's still tight. I can't get it any tighter. So I'm happy with that. I like to put a layer of electrical tape or two around those. Don't put your fingers on that sticky part. That's how you get them to not stick. Now I'll coil these up so we have enough conductor in here to service this. Okay. Now, if you look at the plug, you see how the ground is on top, like so. So that's what we're going to do here, put the ground on top. Technically, these should be flipped around, and the idea is you put the ground on top, so if your plug is halfway unplugged and something falls over it, it hits the ground, not the neutral and the hot conductors, but that's okay. It just seems to be adopted that way, that's just the way people like it. Okay, now I'm going to put my cover on, and I'm choosing to use a raised industrial cover, and we can put a screw in like this, screw in right there. Okay, now we have to get the circuit numbers and mark it. So in my panel up there, I'll mark it as welder A because I have 4 welder plugs in the panel itself. So we know it's circuit 6 and 8, so we go there. We also know it's welder A. Anytime you turn a new circuit on, stand to the side. That way if there is a problem, any sparks or anything is not in your face. Okay, so now what we have to do is check to make sure we actually have 2 separate legs, because that's what it is. This is on one phase of the power, this is on the other phase. So the way we want to check that is we want to take one of them, go here, and go to our ground, which is our bonding, and we're about 118.8, and then we'll take the red out of our one phase, put it in our other phase, and touch it here. On one the other phase we have 117.5. Then we go this way and we got 236 volts. That's what we have across these. Now remember, this is just for ground. This is personnel ground. It's not actually for unbalanced load. So we got about 236 volts. So pretty good supply, and we got it all marked. So we have to do this one more time because down here we're going to add another one. We have a second welder plug here, so I'll get going on that next. Alright, so we got our last welder plug in. Circuits are marked, welders marked, you know, welder B. And let's see, my other 8 lights came in, LED lights, so now I have to start taking these down and start wiring them. But Josh's driver's here with the fire truck, so we got to go meet up with him as soon as it stops raining, and then we'll get back to work. Well, the electric is done. I got all my lights in. So it'll be a total of 16 lights. I only ran 3 down this one. I'm gonna replace this. I hadn't decided. This stays on all the time, so when you come in you can hope, you know, you have a light. But yeah, we're all done, at least for right now. We'll make some more changes next time, but I don't want to give you too much of a sneak peek. But here's Josh's truck. We're already starting to do some work to it. So anyways, hope you guys enjoyed this. If you want to watch this build, what we're doing here is we're going to shorten this up, go from spring ride to air ride, add a hitch plate, do the drive line, all that stuff. That'll be on my other channel, JC Smith Projects. So check it all out. Catch you guys in the next one.